Welcome to a week number insert number here. And this week we're gonna go over the CTF Learn challenges from last week. I made a little different changes with the one from last week. Based on the input from everybody saying that they don't have the time, I chose one that takes the minimum amount of time, in which was it's also a big part of a lot of CTF, in which is ciphers. So the thing about ciphers is been used like a long time throughout the centuries, I believe. If we search, okay, if you go to, if you look into ciphers, the first one I believe would be the Caesar ciphers or different kind of language representation that could be decoded and encoded in order to kind of observe whatever make confuse people or doesn't lead them to the right way, so that you could only specifically communicate to the people that knows what it is and how to crack it. So this one is called the bilateral substitution array. It's using 6 by 6 box, and this is the key for the whole cipher and the way to communicate. So we are discovered, save yourself, and you would just give them this key ciphertext, and then they would decode it, and they would get the answer. Um, this is a big part of CTFs and also a lot of different communication that are meant to be hidden. Um, there is a website called, I believe it's like Decode. Yeah, this website that goes a lot. Well, this one is in. Okay, this you they have a lot of different tools and a lot of different informational texts about cryptography and ciphers in general. Cryptography and ciphers is the lowest level of it. It uses things like frequency analysis and then indexing shapes. So like there's this one called the rail fence, in which is basically just, maybe you just Google it instead of doing one.
At the bottom of the decode.fr, there's like actually an explanation if you just scroll down.
Yeah, I mean, true. Well, this one is with the key of three. It would just put them into three, and it's like a railing, and then the words would just go within the X, and you would concatenate them from left to right per line, so it would just be a bunch of gibberish, and then the original plain text would be that, and then I didn't even see where this. Okay, and this is the ciphertext, right? Um, it's based on shapes. It's based on the key. You could do multiple of them on top of each other. You could do. There's a lot of different way for you to encode your messages so people do not know what it is you're looking at, and turns them into gibberish. The only thing difference about this and let's just say hashing would be that hashing is a one-way function, while this one you're able to recreate the words that you are trying to communicate with. So let's look over. Oh, this is the last one. So whoever finished it, congratulations to you. So what? Um, okay. The first one was they give you one message and they give you a photo. How many people finished this one?
I did.
Okay. Wait, what
I
just
did
happened?
not. All
Okay,
of these challenges I get like halfway, like literally all of them I get like halfway through and then I just like stall every time.
it's okay. Sometimes is when you don't know it, it's kind of very hard to see it through, right? But today I'll show you how should you approach these questions in order for you to get to where you want to.
Alex, did you want me to go through one as
Yeah,
well?
I want you to go through the last one, to be completely honest.
Okay,
Be-
sure.
mhm, because and potential optimization, because I saw your code already. So like I know you were like already like all the top there. Cool. So the photo gives us this. So it gives us some kind of uh 5x5 box with a bunch of letters on it, and we have the cipher itself, in which the cipher text. So we have the cipher text, and we have the key. It wasn't really a key; it was the box with the letters. So how we should go about this is we look. Although it's gonna be useful as you do more of these, and the previous knowledge will be useful, you could always use Google to your advantage by just searching up what it is that you have. So describing your answer things to Google, like we search up real fan cipher here, and it gives us a bunch of example, but this one doesn't use keys. So like that's gonna be not useful for us. So we could just search up like ciphers with 5x5 box, and then it gives you like a lot of different ones. So this one says Polybius square ciphers. You could try that one. Playfair ciphers. Playfair. And then this one is just the image. We could go to and start reading them too, right? Let's we could look at let's do before let's do Polybius ciphers. So first I would probably read into what it does and then see from there kind of why doesn't it work and what does it. This is like the long way. A lot of people just try a lot of different ones without knowing why it doesn't work and just continuously like it's called educated brute forcing, like knowing a bunch of different ones and just continue trying different ones, right? Since we know that there's a lot of different ciphers that has like 5 boxes. So it's used to generate dearranged alphabets that fits the grid. So this alphabet is is a 25, right? It's a 25 letter alphabet. Yeah. Since we have 26, that means there's one missing character, and that's C. Based on the one that we have, the missing character is J. I think J. I think from that, the missing character is J. So let's see if we could recreate the thing. I already did it before here. So it creates just a column thing here. And let's see if we could decrypt it based on a monoalphabetic substitution. Okay. It doesn't really do anything because the fact that there are, oh, what is
Special
that called?
characters.
Special characters. Look at that. See? It's now we have to look for different ones. Before we saw something about a real cipher. No, Playfair cipher.
Alex, no, that's right. Just Polybus only decrypts from what the selection of the letters are. So just remove all the special characters
Ah,
and put it all as
okay.
uppercase.
Let's see. A, O.
Oh no, you can keep the numbers. Keep the numbers. Just the underscore, the brackets. That's all you gotta remove.
Okay, let's see. So Elon suggested that we remove the special characters, but we still keep the numbers, right? And based on that, we still didn't get it. I think. I don't think that was the code. uh, so anybody else have a suggestion on what we should do? Anybody? Alex, do you have something?
Probably Cyber Chef.
Okay.
Yeah, I was gonna just say just Cyber Chef.
let's look into CyberChef. CyberChef is a great tool for us to do these things. Okay, so we input it back here. Let's do without the, the special characters since we know where they are placed. The good thing about this cipher text that we got is within the format that we wanted already. So since they say that the flag was going to be in CTF learn and the words inside, the CTF learn is already corresponding with the uppercase and lowercase letter of this. So it's like CTF learn something. And then the underscore seems to be a representative of something else, right? So with this, we already know that this is the key inside and this is the key outside of the parentheses, and the placement of the underscores, we already know that too. So there are different tools. You could hover over it to see what it is about CyberChef that you want. And I actually didn't use CyberChef, so let's go through this together. So let's see, real fence. Real fence is using a key and offset. We don't have an offset, nor I believe we don't have. Okay, see the key, we don't even have that. So we're looking for particular cipher that allows us to put in an alphabet, and none of these seems to give us a way for us to put the alphabets. So I think CyberChef is not going to help us on this one, I believe. Let's see. We saw before Polybius. No.
It's always helpful to just throw magic on there, and there's a chance it'll
Okay.
detect which type, and then you hit intensive mode, and it'll try a whole bunch. Won't necessarily find it, but it'll try a whole bunch of things.
So the magic is to detect entropy, encoding languages, encoding, like I guess encoding languages, and also it just run it through a lot of different regex like analysis, and you could see all the different languages. Sometimes they give you something or an idea. Sometimes it just like it shakes your brain a little bit to see if
Like,
you could find anything.
what's the probability of like a particular cipher that actually does make use of special characters?
Robin?
What's the chance of a particular cipher actually making use of the special characters in the cipher itself?
Well, the only thing is what kind of cipher it does, right? There is ciphers that does like monoalphabetic or polyalphabetic. That means they're only exchanging the alphabetic structures of it is, right? So they have to, for them to have a way to go back, so reversible functions, they need to go through a key and they need to be a limited key. So if they are saying something about like hexadecimal restructuring, it could work because they're using like the hex number and all the different special characters has a hex number too. But if it's using like an alphabet, they can't use the special characters. So more advanced ciphers would do that, but on a lower level, like for communication, plain text communication, where maybe it is by paper, maybe it is by some other way of communication, like pictures, they usually won't. But there's always a chance. It's a very minor chance, I believe, but this one doesn't give us a lot. It actually just gives us a lot of more special characters that generates because of the encoding text. So let's go back to kind of looking into what we found before. Before we had Playfair Cipher. We saw it on the picture when we searched up the 5x5 line. So let's go Playfair. Okay. They want to give us ads. Can you just give it to me? Okay. This one. So well, let's remove the special characters again, because I think that was a useful advice. And this one is missing the J too. Brute force decryption attack with the grid. Let's see what this does. Okay, so we have this one gives us a CTF learn, a lot of the different ones. Wait, I think I'm not quite sure. Oh, I think this one kind of messed up because it decrypted CTF learn right, but this
I,
doesn't make out into a word or anything like that, or it's not
I
understandable.
I don't think it is CTF learn.
It wasn't?
It was something different. It was like CTF, like CTLEAF, and then O or something.
I also found this other website called Box.
Do you want me to share my screen and show you what I'm talking about?
Um, this one, oh, there's also this one in which is another website. It works the same way as this, but instead of me playing around with the grid, what they ask for is the text, the line underneath it. So let's just run it for that before I let Elon show his screen, right? It's decrypt, and then the encryption key is the long line because this is basically the encryption key. It is. You see, I think it just messed. I'm not quite sure why it messes up, but maybe the special character did play a part. There's a lot of different ciphers that I'm not even sure about too. So I guess in a sense, uh, some website works too, and some website doesn't. So you have to play around with a lot of different ones. And these two are just some of the one that you could Google, and the first thing that they would pop up, I believe. And this is the flag. Did yours was yours this one too, Elon?
Yeah, that's mine. Yeah.
Mm-hmm. Yeah. So uh, maybe it. Wait, let me see something. Okay, the letters, if you see it, the numbers didn't move, and the special characters didn't move. The the O stays there, the 1 stays there, the 4 and 1 the 4. So this is only changing the letters, but I guess with Playfair it doesn't also mess up all the other non-alphabetic non-alphabetic characters. So that's why it works. A lot of different ones. The reason why there's different a lot of different ciphers is just it tweaks a little bit. In fact, there's a lot of rotational one that is like a simple substitution based on a rotation of the alphabet. You know how there's 26 alphabet, a rotation of 26 alphabet is just the same thing. But a rotation of 13 would be you move the alphabet 13 spaces forward and continuously like it was wrapped. And if you were to change it from a rotation 13 to a rotation 12 and a half, let's just say, and you use some kind of function to do that, it actually increases the entropy and then it makes it a lot different than if it was just 13. Um, Anybody have any questions or concern about that one? Okay.
I'm good.
For the next one was a so someone gave me this, haven't an idea what it says. They give you a link to a text file. Figure it out for me, will ya? Did anybody do this one?
Yep.
Anybody else except Elon, in which I think know these things already?
Yeah, I gave it a shot. Couldn't figure it out again.
Okay, Elon, you want to show
Yes,
him?
I did.
Oh,
Yeah,
wait,
sure.
who's
Do you
that?
want me to?
Wait, who said sure I did? Is that Mike? Wait, who is that? Why can't I press no button?
It was me, Bert.
Oh, Bert. Bert, are you able to share with us how you did it, or are you at work and you can't?
I'm still at work, but I remember I just Googled substitution cipher and then went from there, and then I kind of forgot what was in the file, but
Okay.
if you kind of go along, maybe I'll try to remember.
So substitution cipher, we Googling it, and then I believe the file was called substitution.txt, and it gives you this text file. This text file is not that long. It's pretty short. So if we control all, we select all of it, we command it, and then just like Bert did, he saw the word substitution, look for a simple substitution. Oh, this one is just reading about it. Substitution is basically just replacing all the words with different other letters, in which is based on a key. Maybe it's based on this one is a random generated key, but it could also be an alphabet that is shifted, or if it's jumbled up together. The best way to do about this, since it is a substitution cipher, is we could just brute force it. This one's already copy and pasted here. And then we could just decrypt it based. Yeah, wait. Yeah. So it gives you all this text, and they give you the flag if only modern encryption was like this. And you have to plug it into the CTF format, and then I believe that was the answer. Congrats, Bert. The next one was, I believe, more fun ones. These are the lower level entry questions for CTFs, geared toward more beginner or like people who are starting into the field. The next one requires some kind of knowledge, a little bit of a programming language, or if you want to take a jab at a programming language. Elon showed me his because he was really excited about it, and I want him to talk about it. So, Elon, you want to take
Good.
over?
I would love to. Yes.
Okay.
Okay. Cool. So, moving on from the previous one. So, okay, what does this question say? The first thing I did was I started to read the question. I didn't even download the thing yet. So we see that, okay, so we've got a programming language freak, so we'll probably use something with programming language. Cool. The language works like this. So actually what I did is I got a little bit distracted, and before reading the rest of it, I saw stack. So I was like, okay, so stack language. And it doesn't look like there is actually a language. There's a stack, like as in programming, there's queues, heaps, stacks, all that stuff. And this is kind of what this thing says. So I was like, all right, so someone probably made their own language. So I'll read the rest of the problem. And then the next line is like, okay, work somewhat like an array. So sure, someone definitely made this up. And then it describes what a stack is, and then there's some rules here. So our first rule is this minus will just decrease the stack, the element in the stack's value, or the element in the value of the element in the stack by 1. So I'd imagine, okay, so it's got to be a list of numbers I don't know where they start, but down here gives me some clues here. And then, following the rest of the rules, so adding one, swapping, putting the first on the last, putting the last on the first, exchanging the last two, duplicating the last element, blah, blah, blah. And then this is printing it into ASCII. So from all of this, I see, all right, so we start out with some numbers, and by the end of these listing of commands, whatever they are, we end with numbers. And then at the very end, there's going to be some special euro sign, which tells you to turn it into letters. So based on that info, create an output. And then this is the output of the flag. So I was like, okay, cool. So download the text, and then you're given this. So initially I saw this and was panicking because I was like, oh shoot, so I really do have to write my own program. There's nothing I can do online like the other two. There are tools online that I can use. So I was like, all right. So I looked through this. I'm like, okay, so there's no spaces. They're all in line. So it looks like it'll be easy to just like go through each of the characters in this text. And then I see this at the end. I'm like, okay, great. So this looks like proper formatting from the question. Everything matches up. So what I did was I brought this string into a code editor of my choice. I personally really love Studio Code, but you can obviously do this in Python in the actual IDLE that they give you. I was thinking about writing this in front of you, but now that I think of it, my code's really messy, and it'll just be easier if I explain it. So I brought in the string from the text, said that equal to something, and I forgot how to use the split function, so I made my own. And by the way, the entire time I was doing this, I was like, Python, how to, like for each element in list, blah, blah, blah. Like I couldn't remember a lot of these functions because it's been a while since I truly programmed something in Python. That wasn't some basic script, even though this is a basic script. So I was Googling some stuff, and I eventually started programming out based on the rules here. So decrease an element, decrease the stacks element list by value 1. So, sorry. I set up an array, and there's only one thing in the array because here it says initialize it as one element, and that element is 0. So then I was like, okay, great. So I've got the array. Now I can start testing. So I've got a bunch of print stuff for my testing. And I iterated through a bunch of layers, of testing. So I started with, okay, can it recognize a character? Am I doing that right? Great. Can it recognize or actually increment or decrement the value? Great, it can do that. And I just went through and I did all of it. And then at the very end, if it reaches a print in ASCII, this code, actually, I'm going to comment this out and I'll show you. Show you what it looks like, the actual stack itself. Okay, great. So we see a bunch of numbers here. So with each of the commands, and there's a lot of them, it actually goes through and increments, decrements, adds values, blah, blah, blah. And then we're left with a bunch of numbers, which leads me to believe that these numbers are character values, probably in decimal. So I was like, okay, so how do you turn decimal to ASCII? You use the little CHR command that Python gives you. And then I just appended that to an empty string. And then at the very end, I print that string. And that is actually our flag. So all of these characters, each one of these correspond to each of the characters in this string. And that's how I solved it. It was kind of fun. It was actually a lot of fun to solve this. And you'll notice probably with the other challenges as well, you go through a lot of trial and error. So this code looked totally different when I started. And it looks very messy now, but I'm sure I can touch upon it and make it look a lot better. So yeah, I think that's everything there. If you want me to explain any more, if anyone has any questions, I'd be happy to answer questions.
Yeah, so that looks really good, and thank you for sharing. With a lot of problems, although it is not necessary for you to know a programming language, I feel like you should pick up one language that you want to go for, and then because you could use Python, I believe, is the simplistic one. You could just pick up and start doing it right away. A lot of different ones, there's a lot of complication. Like with C, there's different things that you have to worry about, like compiling it and also having a right editor for it. Um, Alex Zimmer knows something about that because he and I have a class in which you need to compile codes. You need to trial and error a bunch of times to see the logic behind something, if it makes sense or not. So maybe pick out a language that you want to go forward with, and then from there you practice little by little, and over time you will get to know a lot of it. Python have a lot of different syntax in which is really helpful with like text manipulation. Also, like they have a lot of different modules and would allow you for like networking purposes, scripting on your computer, creating secure shells into another computer, like a virtual machine or a network device from the kernel itself. Things like that is really cool. You guys have any question to me or Elon's code? That seems like a lot of comments. My code doesn't have comments at all. And when you read it afterward, you just get confused in what the use of it is.
Yeah, I should explain that this is very messy code. Honestly, the word hack comes from hacking something together, quickly, bringing a lot of disparate things together so that some functional solution appears. So this is very, very hacky code, kind of in the spirit of all of this stuff. So, and like I'm human, so Alex might not be human, but I'm definitely human. So I created a really tiny example, and I really tested out all of these things a lot, on paper, and then I started actually programming this. So that's why it looks really, really messy, but only because it was a lot of trial and error. I had to get used to Python again, and then catch up. But overall, it's fun. You learn a bunch of stuff.
Anybody have any question?
No, I mean, you just said you basically have to practice at a programming language so that you can start putting this somewhere where you can start making sense of it, right?
Yeah, that's always the case. And for the next few weeks, Elon is going to take over the explanation for the Tuesday meeting as I prepare for another competition. So, I'm gonna still be here, but I just want to give you guys a heads up. Yeah, and I think that officially concludes our presentation today.